Hello everyone, I am Nandini, EPS third year student, and today I am here to present on the topic HRV Biofeedback Device for my applied instrumentation presentation. Let's start. The first question that we think after hearing this topic is, what is HRV? HRV stands for heart rate variability, which is nothing but the variation in time intervals between consecutive heartbeats, which is regulated by the autonomic nervous system, and this provides the insight into the functioning of the cardiovascular system and thus the overall health of an individual. Now, the other things that comes to our mind is, what is a biofeedback device? Biofeedback device is nothing but a apparatus that we use to measure the physiological changes that are occurring in our body and somehow they are affecting our body. So now we combine these two terms and we are getting HRV biofeedback device, which is a device, a tool that is used to measure the HRV and provide real-time feedback on physiological and psychological states of an individual, which can thus be monitored into, and the steps can be taken to regulate and improve the overall health of a person. The working principle that is involved in our apparatus is, we make use of sensors, signal processing unit, and thus we have a feedback system which gives the output, and thus a user can adapt accordingly their habits to improve the overall health. So in the sensors we have ECG sensors which are going to detect the heart rate, heartbeat, and these sensors are placed in the form of chest straps, wristbands, fingertip sensors, or another pulse checker kind of thing, which can be placed on different parts of the body according to the use and the design of the equipment. Then next we have signal processing unit, which converts the collected data from this which we get through the sensors, and this data is processed and ultimately some output is generated, which is given back to the user in the form of some feedback, which can be thus used by the user to improve their health by accordingly seeing the variation in the output. So what all the equipments we have in this HRV device are hardware components like sensors, microcontrollers, power source batteries, protective casing, wiring, etc. The microcontroller or data processing unit, as I have told, it converts the ECG signals which are collected by the sensors and calculate the HRV parameters, and thus simplifies whatever the data we are getting into a user readable format. Then we have ECG sensors, and we have display output mechanism, which can be in the form of some visual data output or some audio output that the user is getting. Next, the circuit design and the software integration. Since it's not very easy to get the data, and the data is not in a readable form, so we have to process it within the system, which is done by the signal processing unit. And for that we use HRV algorithms, which are used for calculating various parameters, which are like standard deviation of NN, which is known as SDNN, or root mean square of successive differences, which is RMSSD. These are nothing but the parameters to detect the heart rate. NN stands for normal to normal heartbeat, and both these terms measure the heartbeat rate, how it is affected and how it is changing over the time. So we use the algorithms to measure and see what are the differences coming and how the user can tackle it. Then next we have user interface, which is developed by incorporating some software and thus displaying the data and providing real-time feedback to the user. Here is the diagrammatic representation of what all goes on. So here's a person who is having some thoughts, and due to that the heart rate is changing. Now suddenly every time the monitoring unit or the sensor, in this case we have pulse sensor, it senses the heartbeat, then it sends it to the acquisition unit, which further sends it to the biodata processing unit, where the output, whatever the beats or the data that our sensor is capturing, that is processed, and further after processing it, output is generated in form of graphic visualization, which can be audio generation also, like some beep or some buzzers kind of thing, which the user gets to know that there is some abnormality. If in the case is there, then he or she can incorporate any stress relieving mechanism or practicing like deep breathing or anything to just relax the body and mind, and thus improving the overall health. In the next diagram, what we see is a comparison between the normal NN rate and RMSSD. So if we just look at NN and or normal rate in sample A and sample B, there is not much major difference. But if we take the RMSSD, then we can see there is a huge difference, and this difference is like used by the signal processors unit, and thus uh, feedback is generated which helps the user to take care of their health. So the main equipment used in this HRV biofeedback device is ECG. So let's take a brief look at what ECG is. ECG consists of electrodes which are placed on different body parts to detect the electrical activity of the heart, and these electrical signals are generated by the heart during each heartbeat. These are captured by the electrodes and sent to the ECG machine, which then records, amplifies and filters these signals, and in turn generate ECG waveform, which represents the depolarization and repolarization of the heart's chambers. Then we have leads, gel, wires, electrode paste, which are the basic equipments used to complete the circuits and all. Now this electrode paste is having one more use, which is like providing extra electrical conductivity for the signals. Then we have ECG monitor, which outputs the data whatever we are receiving in a user readable form. Now we have different operating modes of our HRV biofeedback device. The device can be of any shape or form, but like it can be a standalone device which is independent with built-in displays, or it can be integrated with some wearable equipment like smartwatch, wristwatch, and it can be integrated with the smartphone also in form of some apps. So it comes with the HRV biofeedback device has wide applications now. Thus we can see like our day-to-day life is so much stressful. So if we use HRV biofeedback device, we can get to know what is going on internally, and thus we can regulate our not heartbeat exactly, but we can check what is happening with our heartbeat, and accordingly we can practice some meditation, some stress relieving exercise or something as soon as we get some feedback. So it has applications in healthcare, sports and workplaces. Athletes can use this biofeedback device for their overall performance betterment, and in workplaces for stress management and productivity enhancement. Now we can conclude that our biofeedback device HRV offers valuable insights into the body's stress response and thus the overall health of an individual. Now this field is continued in research and innovation, because further it can be improved by means of instrumentation like size reduction or more capable technological advancements. So thus it's a very potential research field also. Thank you.